Welcome back. So we've got three claims here that we're going to try and investigate. These will be the three claims that we carry through the rest of this series, where we are going to do a full hypothesis test, which is we're going to hypothesize based on our claim, test using sample data, and make some conclusion or something about in conclusion, as the case may be. But first of all, again, with three claims, and we want to make null hypotheses for each. Remember what I said in the last video that whenever you're making a null hypothesis, it always equals to a number. So for these three claims, it's going to be equals, 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 always equals for the null hypothesis. The first claim was less than 3.0, so 3.0 became our hypothesized mean for the null hypothesis. For the next one, we claimed less than 100, or I'm sorry, over 175 pounds. So we had a null hypothesis of equals 175. And finally, we claimed that the mean body temperature for adults is 98.3 degrees Fahrenheit. So that became mu equals 98.3 for the null hypothesis there. Moving forward, the alternate hypothesis should be related to both the null hypothesis and the claim as best as possible. So here we claimed it was less than 3.0, so less than 3. In the second claim, we said that the male weighs over 175, so the alternate hypothesis was greater than 175. For the final claim, we claimed equality. And so here's where things get a little dicey, because null hypotheses are always equality, and the alternate hypothesis has to be something different. So it can't be equals here, and really it shouldn't be greater than or less than, because that's kind of when we claim greater than or less than. So the only sign left to us is not equals. And that's what we use here. Because we're using equality in our claim, and we've used equality in the null hypothesis, that means we have to use not equals in our alternate hypothesis. Okay, great. We've got our hypotheses made. You'll note here that I say take alpha to be 0.05 just because I want to have something to work with, right? If money was at stake, I would use a lower alpha value. If I really didn't want to be wrong, if I didn't want any false positives or false negatives, I would be more careful with my alpha value. But for this course, at this stage in the game, we'll just take alpha to be 0.05, and we'll change it later. Well, not later, wait. If we did a different test or we needed a different value, we would use a different value. So we're good to forge on ahead, right? We've got our sample. Oh, wait, we don't have our sample. That's what we need next. So let's go get some sample data. Let's go measure some earthquakes or look up measurements. Let's go weigh some adults or look up weights. Let's go take temperatures of adults or look that up. And so, yeah, hang on. So let's say we do that. And now I have a whole bunch of weights or a whole bunch of magnitudes or a whole bunch of temperatures. We're going to need a few things. We're going to need the count of data points we're using, which we can just count. We need our sample mean and our sample standard deviation. So as a quick review here, if you're calculating those things by hand, you can just count by hand the number of data points you've got. Define mean, of course, you'll add the number of data points, divide by the number of data points you had. That's your mean. And to do standard deviation, it will take a little bit of effort because it is the difference between each data point and the mean. So you'll take 18 here for this example, subtract that away from each data point, square each of those differences, add each of those differences together, and then divide by n minus 1, and then take the square root of that. So hey, if you want to do that, knock yourself out. We've done it in class. We've done it before. You can handle that. If you don't want to do it by hand, I understand. So if you want to use Excel, you got to open Excel. And then you can type all the data into one column, or you can do it however you want. Equals count, equals average, equals standard deviation, and that will give you your values. Again, you'll note they agree with what we had over there. And then you can also do it with Desmos as well. You can copy paste or type it in like this, and then do mean and standard deviation. And again, we're going to get mean and standard deviation. So now we've got to calculate our test statistics. So if you want to do that now, go for it. If not, I'll see you in the next video.